7, adding and subtracting rational expressions. I want to remind you that a rational expression looks like something that is represented in a fraction where a and b are elements of the integers. Okay, that sign is just elements and this is integer. Okay, so a and b are just elements of the integers, and remember that b cannot be equal to 0 because that would make it undefined term. If it's undefined, we obviously can't do anything with it. Okay. Alright, so just a reminder how that works. Now when we're talking about rational expressions, it holds the same kind of definition, but they're going to talk about something that's a function over a function. And still the same thing stands true here. We cannot have the bottom equal to 0. It cannot happen. So for the polynomial f of x and for the polynomial g of x, where g of x cannot be equal to 0 and g of x is of a degree greater than 1, this would represent a rational expression. The rational expression is basically, instead of just a regular old number, it's just something with a degree greater than 0, or greater than 1. Alright, so the definition of that isn't too much to do with what we're learning, but we need to know what the difference between an irrational and an irrational one would look like. So there's your definition. Example 1a. Now, our rules of adding and subtracting rational expressions will hold the same as if we were adding or subtracting regular fractions. Okay? So if our denominator here is 2x, in order to add it to something else, our denominator must be the same. We have to have a common denominator. Okay? So since these are already common, we just add the things up on the top. So 1 plus 3 over our common denominator, which stays common the whole time. Okay, so that goes down to 4 over 2x. Now this can be reduced just like you would have done before. So once you get down to your answer, just look at it like, can I reduce this? Yes, I can. It's 2 over just x. Okay, and keeping in mind what our excluded value would be here is x cannot equal 0 at any point. Okay, any questions thus far? Okay, they build really quickly on this, so they already are moving on to x over x squared minus 2x plus 1. So they've already started building, making rather larger denominators. When we start doing that, we'll start seeing things that aren't common denominators, and we'll have to find a common denominator, and they'll look like this. And then it's the same one here, so that's nice. We already have a common denominator. And up top we have 1. So when I rewrite this, it's just x minus 1 and x squared minus 2x plus 1. Now, you want to keep in mind that when we did rationalizing, when we did simplifying rational expressions, we broke this apart because we end up with stuff that looks like this, x minus 1. So if we can get something that looks like x minus 1 here, we can simplify this rational expression. So what I'm going to do is I'm just going to factor the bottom part of this out. I'm going to factor the denominator. So since this is x squared minus 2x plus 1, I know that since I have a plus sign here, it's going to be same sign sum. Since it's a negative there, that same sign is going to be negative. Since it's just x squared up front, I'm going to put my x's up front. Since 1 is prime, I don't have a choice. I'm just going to put 1. So I factored it out, and I see that those cancel. So I'm left with 1 over x minus 1. And that would be my final answer. My excluded value in this case would be a positive 1. It's because it's where x minus 1 cannot equal 0. Okay, so since I had that term in common, I can cancel it out. But that only works when you factor. You have to factor before you simplify. C. Now this one is a 3-piece deal. So instead of writing this denominator 3 times, okay, so everybody look at this. Instead of writing my denominator 3 times when you write it on your homework, just write the top parts all together and then one common denominator. Since it's already a common denominator, you can combine it already. So when I write this down, it's going to look like 2x minus, I'm putting this in parentheses because I got to distribute out this minus here in a second, x plus 2, close parenthesis, plus a negative 1. And then it's all over that common denominator, which was x squared minus 4x plus 3. Now I'm going to go ahead and factor out the bottom piece just in case I can simplify something here in a second. So I'm going to set up my two parentheses, 1, 2. Back sign says same sign sum. Middle sign says that both of those signs will be negative. Since the front is prime, I'm going to go ahead and put my x's. Since the back is prime, I'm going to go ahead and put my factors. So there, since everything was prime, that made my life really easy. Now I have to just simplify the top, or combine what I can. So since this is negative, I need to distribute out this negative. So I have 2x, because I didn't do anything with that. I'm going to distribute out my negative to the next x and to the 2. And then that leaves me with a plus and a minus right next to each other, so that's a minus 1. Okay. Next step, I combine like terms. So I have a negative x and a positive 2x, which makes just a regular x. And then I have a negative 2 and a negative 1, which makes a negative 3. And that's all over x minus 3 and x minus 1. Saxon is really nice that they set these up to where you can normally cancel stuff out. Okay, so you're not really doing work for nothing. 1 over x minus 1, yep. And r, if we were looking for excluded factors, or sorry, excluded values, it would be positive 3 and positive 1 would be my excluded values. Okay? I look at the original, not what I'm left with when I'm done. Okay. Any questions there? Oh, sorry, I didn't mean to make a line all the way through that. Nothing? Okay. Example 2. So this is starting to explain where we need to find a least common denominator. So if it gives us two numbers, for example, 1 over 2x and 1 over 7x, and it says find a least common denominator, I want to find multiples of each of these numbers that would give me a common multiple. Okay, so looking at these two, what do you think? If it was just 1/2 and 1/7, what would the common denominator be? 14. So here we just have an x added onto it. So you just need to consider this like a multiple where x is in there. So our common denominator will be 14x. So that one's simple, but if I needed to write it out, if you needed to multiply all these out, you would look at it as multiples of, so 2x times 1 is 2x, and then 2x times 2 is 4x, and you could list them all the way out, 6x, 8x, 10x, 12x, 14x, and then you would list out the multiples of 7 and see where they finally have a common one in there. But it's easier if you use your calculator. So if you don't have a calculator, go ahead and grab one. Okay, so on your calculator, press the math button where it says num, which is number, by the way. There's a button that says least common multiple. Yep. So when you type in LCM, this won't help you with the variable part of it, but it will help you with the coefficient part of it. So all you do is you type in the coefficients to find your least common multiple and coefficient. So it's 7, comma, and 2. Comma is right above the 7. And you press enter and it spits out a number for you. Okay. It also has a greatest. It has another one on there, guys, if you want to use it. This will find your greatest common factor. It says GCD, but it's actually greatest common factor. Okay. Factor. I have no idea. You would think, but that doesn't make sense. Anyways, that's another function that you can use, but for this one you only need LCM. Okay, so fun fact. So there's your least common denominators, 14x. On the next one, it gives you a little bit different of a problem. So here they have 1 over x squared minus 4. So I'm going to have to factor out this bottom one. Now you should notice that it's a difference of 2 squares. So this one's a perfect square and this one's a perfect square. So it should factor out rather easily. So x minus 2 and x plus 2. Difference of 2 squares, different sign difference. So that one worked out. The next one is 1 over x squared plus 5x plus 6. So again, I'd have to factor that out. So I set up my two parentheses, start asking myself the questions that I need. What does the back sign tell me? Same sign sum. What does the middle sign tell me? That same sign is going to be positive. I look at the front, it's prime, so x's go up front. I look at the back, it is not prime, so I need to factor out 6. Factors of 6 that when added together will give me 5 are 2 and 3, good. So now I look. This is a common factor. These are my common factors. So what would I need to multiply this one by, and what would I need to multiply this one by? So it seems just like we would do, okay, so we're looking for least common multiple. So if this one is multiplied by x plus 3 and this one's not multiplied by x plus 3, we would multiply it over here. So what it would look like is we would take this x plus 3 and put it on this side. So whatever this one has that that one doesn't, we would have to give it to that one to make it common, because what we want is for each of them to have the same thing on bottom. So since they both have an x plus 2, then this one has x minus 2, so this one needs to go over here. Okay, so our common denominator will be basically all of the things that they have on bottom, and you don't want to repeat it. So it looks like x minus 2 in parentheses, x plus 2 in parentheses, and then the x plus 3 in parentheses. So all I did was take one of each of the things that I had on bottom. I wouldn't repeat it since they had this one in common. I just don't repeat it. And my common denominator is all of this right here on the bottom. In order to simplify that, I would have to multiply it all out. But in this case, it doesn't ask us to do that, so we don't have to. Okay? So I think we should do another example of that one to get it extra clear. So give yourself a second to get caught up there. I'm pulling this one from the lesson practice on page 269H. Okay, so it gives us two expressions. One is 8x squared minus 22x plus 15. Okay, so I'm going to have to factor out that, and it was being subtracted from 1 over 2x squared plus 13x minus 24. And then I'm going to have to factor out that one as well. So I'm going to deal with these piece by piece. So I set up my two sets of parentheses. First I want to look at this and see, can I get rid of or make this a smaller? Can I simplify it at all to make this a smaller number? No, unfortunately we can't. What about this one? Can I do that? Anything to that one? No. So I guess we're doing it the hard way. So we're going to use the AC method on this one. So I'm going to take A, I'm going to multiply it by C. So that ought to give me, what is that, 120? 8 times 15 is 120?
Yes.
Awesome. So I'm looking for factors of 120 that when added together give me 22. Factors of 120 when added together give me 22. 10 and 12, right? So I'm going to put 12x on one side and 12x and 10x, my bad. 12x and 10x on opposite sides. And I'm going to use that as a reference. So now I want to look at my factors of A. So since A was 8, I'm looking at 8 and 1, 2 and 4. And I think that's it. And I also want to look at factors of C, which was 15. So factors of C would be 1 and 15, 3 and 5. Is there anything else?
No.
Yeah, I can't think of anything either. So I'm going to look at combinations of A and C that will give me 10 and 12 when I put them together. 10 and 12. It looks like this one and this one. So my 2 would go with my 5, which would make a 10. My 4 would go with the 3, which would make a 12. So remembering that I need to multiply here and here, insides and outsides, to make those, I would say, okay, I want my 3 to be multiplied by my 4, so 3 multiplied by my 4, and then I need my 2 multiplied by my 5, so I'll put my 2 and I'll multiply that one by my 5. So now I just fill in the blanks. Since the back was positive, that's same sign sum. Since the middle was negative, that same sign is going to be a minus. Since that's just x squared, I'm going to put x's up here with them. So I factored that out. Wasn't super easy, but it's there. And I can quickly check it. So it's negative 12x, and that's positive 10x, and it works. So now I have to factor out the other one. So I'm looking at this one again. It looks like I'm going to have to do the AC method. So AC is 2 times 24, which is 48. and I'm looking for factors of 48 that when subtracted give me 13. So factors of 48 that when subtracted give me 13. Factors of 48 that when subtracted give me 13. I think it's 16 and 3. Somebody check it for me, would you? Yeah. Okay, so since it is 16 and 3, I'm going to start setting up my parentheses. I'm going to look at the middle sign. It is positive, so I know that my 16x is going to be my positive one, and my 3 is going to be my negative one. Okay, so remembering again that I'm looking inside and outside, I'm going to factor out my front. So since my front is going to be a 2, okay, since my front is going to be a 2 and a 1, I need to think 3 isn't even, so I can't put my 2 there. So that 2 has to go with the even number. So therefore my regular x just goes with the 3. Then I have to look at factors of 24. So factors of 24, 1 and 24, 2 and 12, 3 and 8, and then 6 and 4. So they're all my factors of 12. I need to figure out, well, I already know what's going to go back here. A 3 is going to have to go back there because that's the only way to turn an x into a 3x. How do I turn a 2 into a 16? I go by 8. So 8 and 3 is my winner. Now I need to figure out where my signs go. Since this one's negative, I'm going to put my sign there. Negative goes right there, and therefore positive must go on the other side. Quickly recheck it. 16x and 3x. Say it again. 8 and 3 because 8 and 3 make 24, but I knew that my 2 was going to have to be here. So all I did was take 16 and divide by 2. Got me 8. Does that help? If I look at A, which is 2, the factors of A are just 2 and 1. So I want to use the factors of A and C to combine and make. Okay, good job. Since A was prime, I didn't do it. That's when it's prime, I don't write them down. Sorry. All right, so now I'm looking at everything that I have on the bottom. I notice that this is that they already have that in common. That 2x minus 3 they already have in common. So that's the first one I'm going to write down, 2x minus 3. And then we'll look at what they don't have in common and just write them down as well. X plus 8 and then 4x minus 5. That is my common denominator. No. Because multiplication is commutative and associative, it doesn't matter. Okay. Now, just like we would do, I would ask you, what do I have to multiply this by to make it a common denominator? So I look here, I have an x plus 8, and I have a 2x minus 3. I would have to multiply this by a 4x minus 5 to get a common denominator. So 4x minus 5 gets multiplied on the bottom and on the top. Okay. So when I do that, I have to multiply both top and bottom in order to actually solve the problem. And then when I look over here, I do the same concept. I say I got 2x minus 3, I got 4x minus 5, all I'm missing is the x plus 8. So if I multiply the bottom by x plus 8, I must do that also to the top. So now I have a whole new problem. This is taking up a lot of paper. I have x plus 8, right, and this is being subtracted. So minus a 4x minus 5 on top, and then I have that big long common denominator, but again, it doesn't matter what order it's in. Like that. And then I'd simplify the top and leave the bottom common. So I'm just going to do a little squiggly for the bottom is the same. Save a little bit of time here. X plus 8, and then I distribute out my negative. I get minus 4x plus 5. Combine like terms. I have an x and a negative 4x, which makes a negative 3x. I have an 8 and a 5, which makes a 13. And I am done. And all I have to do is rewrite my common denominator. Now, I know that this is time consuming, but it's not difficult. The hard part is factoring. But once you get past the factoring part, that part is not difficult. So if you feel like you're not getting it or you're overwhelmed, just ask right away. Don't get frustrated with it. Okay? Just ask right away. Let's get back. So to jump past example 4, all you'd have to do on that one is make sure that what you did on the bottom you also did to the top. So here it says 1 over 3 x to the third plus 1 over 6 x squared, I need a common denominator. So when I'm looking at this, I see x to the third and I see x squared. So I know that I'm going to have to multiply this one by an x to make this x to the third. Okay? And I know that I need to find a least common denominator for a 3 and a 6. So that's going to make it 18 when I combine it, or 6, whichever one you feel comfortable with. A lot of people just want to multiply that, but with our calculator function, it'll help you find the least common, which is actually just 6. So if my common denominator is 6x to the third, I have to ask myself, what did I multiply this by to get 6x to the third? I multiplied it by 2. So what I do to the bottom, I must do to the top. So now this is 2 over 6x to the third. And then right here I say, what do I need to multiply 6x squared by to get 6x to the third? I would need to multiply it by an x. So what I do to one side, I must do to the other. And I get 1 times x, which is just x, over 6x to the third. So my final answer is just 2 plus x over 6x to the third. And that's as far as you can go. You can't do anything else to it. Somebody's going to try to do this, but be careful. If it's not factored, you cannot divide out this 2. If you are not factoring it out, you cannot divide it. Okay? It has to be in some form of multiplication in order for you to divide it. Okay? So what you do to the top, you must also do to the bottom. Not really. Yep, that's it. Example 5. On a round trip by a car, it took 2 hours longer for the return trip than it did for the first leg of the trip. How much faster did the car go on the first part of the trip? So we want to keep in mind dirt, right? D equals rate times time. And then we want to isolate what we're interested in. So here it says that we're interested in isolating, looks like speed. Isolating speed. So in order to isolate speed, we would take the t and divide by it, right? So now we have rate, which is our speed, is distance divided by time. So now that I have that together, we want to look at our 2 rates. It says how much faster did the car go on the first part. So we got the rate of the first part of the trip minus the rate of the second part of the trip. Okay? So it wants to know what's the difference between the 2 rates. So we're just going to use this formula to do it. So the first part of the trip, the rate was whatever our distance divided by our time was. So that was rate 1. But at the second part of the trip, on the way back, it was the same distance. We traveled the same distance, but it took us longer to do that. It took us 2 more hours. So when I plug these 2 things in, I get distance divided by time subtracted from, I'm just plugging these in right here, subtracted from distance divided by time plus 2. And then I ask myself, what is my common denominator? Well, here I have a t plus 2, and here I have just a t. So this one needs a t plus 2, and this one needs a t, because they don't have that. So our common denominator is t plus 2 times t. So since this one got a multiple of t plus 2, I must also give that to the top. So that one gets a t plus 2 up top. And since this one got a multiple by 2, I'm going to also do that to the top. Simplify it as much as I can. I'm going to distribute out the d to t and the d to the 2. So I get dt and 2d, and then I subtract, and it subtracts dt, and it's all over my common denominator, which was t times t plus 2. And then simplify it. Negative and positive dt go away. I'm left with 2d over t and t plus 2. And unfortunately, because of all the information that they gave us, that's as far as we can go. But if they gave us a distance, we could find something else. If they gave us a time, we could find something else. This gives us a general formula for plugging it in. Basically is all it does.